Welcome to our supply chain simulation for a wooden table company. Self-assembly furniture is now a growing trend, as seen in IKEA's business. Is it actually profitable for the business owners? Using a discrete event simulation model to analyze different supply chain and assembly strategies, our project seeks to determine how can a wooden table company optimize its supply chain and assembly strategy, proportion of factory assembly and self-assembly products, to maximize overall profits? Here's the possible use cases and users of our simulation. Let's take a look at the manufacturing processes. Here's the overall model of our supply chain processes. The first step is to process the raw material, which is the wood. Next, the wood will be sanded to smooth the surface, ensure safety, and improve the appearance. The next step is to stain the wood for the factory assembled woods. This is applied to have a sense of quality differentiation for factory assembly and flatpack assembly. Now, to the most important part, which is to inspect the processed materials. All the processed materials are then packed based on its type. If it's factory assembly, the workers will assembly it first, then pack it up. For the self-assembly, it will be flat packed. Now, moving towards the last steps, the assembled table are transported to the warehouse, and lastly delivered to the customer. This is our overall simulation model, starting from the raw material harvesting at the very left and ended up on customer at the very right. The upper part of the model is the factory assembly processes, and the lower part is for flatpack processes. Moving on to the model inputs. Users are able to adjust all the inputs. The inputs are in the red-colored text. Here is the most crucial input, the ratio of flatpack and factory. Users are able to determine the ratio to see which ratio is the most profitable for the business. Lastly, is the model output. We have provided a dynamic and real-time data and graphs tracking for the financial aspect needed to determine the profitability. We have conducted a steady-state analysis for our model to understand how the system behaves in the long run after all temporary startup effects have worn off. We tried different combinations of factory flatpack assembly to determine the optimal proportion, considering also a varying number of workers. Lastly, we run the simulations with varying seeds to eliminate bias. Here are the different combinations we tried, a total of 105 combinations. This is the data of all possible combinations, consisting of the profit per table and how long does it take for the model to stabilize. Here is what the model tells us. For the balanced strategy, profit remains consistent, but additional workers do not significantly boost performance. For factory-only production, it delivers the highest profit per table, with higher confidence intervals. However, it requires longer to stabilize. For flatpack only, it offers stable, predictable profit and the fastest stabilization time, while per table profit is lower. Overall, the model is reliable enough. It remains consistent even with varying seeds. However, lack of variability like the workforce problem might limit the realism of the model. To better evaluate the model's behavior under long-term operational conditions, we conducted additional simulation runs using a fixed time horizon across all configuration combinations. This approach allowed us to compare performance fairly over an extended period. Our key findings were that for the 50-50 split, more workers didn't boost output significantly, which suggests a saturation point. Factory assembly gave the highest profits overall, but adding workers had little effect, just like in balanced strategy. Flatpack simulation produced the most tables. It had lower revenue per unit, but nearly matched total profits due to high volume produced. In conclusion, all setups had similar profits. Factory assembly earns more per table, but flatpack wins on output. Both are viable depending on business goals. The current analysis shows that a fully factory-based setup yields the highest steady-state profit per table. However, further exploration with the splits and adjustments to key inputs could offer deeper insights and help identify a truly optimal configuration.